Okay, here's an example of a vertical sag curve. And as you can see, we're given some information. The curve is 1,600 feet long with equal tangents. The PVC is located at station 120 plus 00, and that's at elevation 1,500 feet. The initial grade is negative 3.5%, and the final grade is plus 6.5%. Basically, what we want to do is fully describe this vertical curve in terms of its stations and elevations. So we would like to find the elevation and stationing of the low point, the PVI, and the PVT. So the first thing I'm going to do is draw the picture. Now that we've drawn the picture, and by the way, I'm a big fan of drawing the picture carefully so that you can make sure that you're solving the problem correctly, there's a little bit more information we can add to the given information since we know that this curve is 1,600 feet long. We know that the station of the PVI, which is in the middle, is going to be 800 feet from the PVC, so we can write in 128 plus 00. And then, of course, we know also the station of the PVT, which is the end of the vertical curve, which is going to be 1,600 feet from the PVC, so we can write in 136 plus 00. And, of course, these tangents extend like that. So we're going to calculate a couple of things. The first is the absolute value of the difference between the grades. So that's always G2 minus G1, the absolute value. So G2 is plus 6.5 and G1 is minus 3.5. So the value A for this problem is 10. And we can calculate the offset at the middle of the vertical curve, and we have the formula y sub m is AL over 800. So A is 10, L is 1,600. So remember that the value of A is expressed as an integer here. And so the offset at the middle of the vertical curve is 20 feet. So I think that means we can calculate the elevation on the curve at the PVI, and we can calculate the elevation on the tangents at the PVI. So the PVI equals the elevation of the PVC minus 800 feet times 0.035, which is the slope. So the elevation of the PVI is 1472. And so the elevation on the vertical curve is just 20 feet higher than that. So I'll write that here, 1492. And then we can calculate the location of the low point in this case. So they're on the sag vertical curve, we're interested in where the low point is. And from just looking at the picture, you can identify in this case, because this slope is larger than this slope, that the low point is going to be somewhere over here. So I'm just going to draw a dot there for now. And we're going to use the equation for x high low, which is the following: LG1 divided by G1 minus G2. So in this case, L is 1,600. And we keep the sign of the grades. So G1 is minus 3.5 as an integer. And then G1, I'm sorry, I left out the minus sign. Minus 3.5 minus 6.5, which is G2. So the solution to this is 560 feet. So that means that the low point is going to be 560 feet from the left, from this PVC. So if we add this to the station of the PVC, 120 plus 00, we obtain 125 plus 60 as the station of the low point. So it's approximately here. And so we can determine the elevation on the tangent at the low point. So following a similar procedure, 1,500 minus 560 times 0.035. And so the elevation there is 1,480.4 feet. So that's the elevation at this point. I'll just make a note. So what we need, of course, is the offset at the low point in order to determine the actual elevation on the curve. So the offset at station 125 plus 60, our general equation for the offset is always ax squared over 200L. So we know that A is 10. X is the distance here, 560 feet, squared divided by 200 times 1600, which is our length. So Y is 9.8 feet. So that's the value of the offset. So the elevation of the low point on the curve is 1,480.4 feet plus 9.8 feet. So we can do that kind of in our head, 1,490.2. The last thing that I have not done is the elevation of the PVT, so I can quickly do that before we finish. I'm just going to slide this up a little bit. So the PVT, and I'm just going to start at the beginning. So it's going to be 1,500 minus 0.035 times 800 plus 0.065 times 800, and that comes out to be 1,524 feet, so 1,524. So now we've fully described our vertical curve. Thank you very much for your attention.